This is the third video in the series for species in solution, and in this video I'll take you through a strong acid. Strong acids fully dissociate, which means that they produce a lot of ions, and that makes them strong electrolytes. Examples of strong acids include hydrochloric acid, sulfuric acid, and nitric acid. Start with an equation with your acid that you're dealing with and show it reacting with water. So here the proton will come off, which will produce the conjugate base, the chloride ion here, and the hydroniums. The most important thing to note here is there is in fact no HCl molecules because they fully dissociate. The other point to note is that in this reaction you do produce hydronium ions, and it is a 1-to-1 ratio, so the concentration of our hydroniums will be equal to the concentration of our chlorides. So when you are asked to put the species that are present from highest to lowest, starting with water, because that's always going to be the highest at 55.6 moles, note the absence of HCl. It is not put down in this list because it is fully dissociated and no longer exists. I do, however, now have the chloride concentration and hydroniums, and this time they are equal. This reaction produces a lot of hydronium ions, and it is not going to have a pH of 7. So if we look at these last two here, the hydronium and hydroxide, this is what you'd expect for an acidic solution. The hydroniums are present in a much greater concentration than the hydroxides. So those are all the species that are present in an aqueous solution of hydrochloric acid. Now let's do the graphical representation. We start with the water bar to the left, and it's the highest. It's broken because of the 55.6 moles. We know that our chloride concentration and hydroniums are equal, and the question will tell you the exact concentration you started with. So in these graphs we always assume it's 0.1. So that's why the chloride concentration is 0.1 and the hydronium concentration is 0.1. It goes back to the fact that from this equation you always produce a 1-to-1 ratio, and that's why those are the same height. Okay, 0.1, 0.1. The hydroxide bar definitely needs to be put in. You don't need to work out the numbers, but it will be considerably lower than 10 to the negative 7 because of the acidic nature of this solution. So that is a strong acid in terms of the species present listed and the graphical representation. Catch me in the next video for a strong base.